Hello everyone, this is Dr. Zach. As you know, related rates take a bit of effort. Today we will be exploring more related rates just to make certain you have had enough practice. So let's get started with this. For today's lesson preview, you are asked to work with particle movement. Now, because you have been paying awesome attention to what we're doing in this course, you know that you should probably rewrite the problem using some algebra. Perhaps you rewrote the problem as 5x times y to the third equals 8 plus 8y squared before you began. When you do this, you avoid using the quotient rule and just have to worry about a little product rule. Now, as you were reading through the problem, you saw that your x coordinate was increasing. So dx dt was given to you, and that was 6 units per second. Make certain that you're following the steps. When you can draw a picture, draw a picture. Write down what's given, and make certain that you write down the question. At what rate is the y coordinate changing? So we have our dy dt, specifically when we're at the point 1, 2. So make certain you state the question and then start to substitute and fill in all the missing information. For your second question, did you draw a picture? I know it's a fancy picture, you have to draw that circle. Did you label the part of the picture that was changing, specifically the radius? And you should put variables on the picture for the pieces that are changing. Now, the area was increasing at a constant rate. So you wrote your dA dt as you're given, and make certain that your units are sensible. Area would be squared and time is hours. So that does make sense. The question was asking how fast is the radius of the spill increasing? So we are looking for dr dt when the area is 9. So you're going to have to do a little bit of work. You need your area equation for the circle, substitute, find derivatives. There's all sorts of good things going on here. So if you have any questions about this lesson preview, make certain you get some help immediately. So we're going to now look at a problem that involves similar triangles. We have a conical funnel. It is 14 inches in diameter and 12 inches deep. A liquid is flowing out at a rate of 40 cubic inches per second. How fast is the depth of the liquid falling when the level is 6 inches deep? So as we draw the funnel, keep in mind the size of the funnel does not change. And because of that, we are going to just put the numbers directly on our picture. The radius is 7 inches. And the height of the funnel is 12. That's not changing. Now, what will be changing in the problem that we're looking for is the rate of change of the liquid that's falling out of this funnel. Now, because the liquid is changing, we're going to put labels to represent the parts of our picture that will be changing. In this case, the radius of the liquid and the height of the liquid. We're told that the liquid is flowing out at a rate of 40 cubic inches. Let's look at that closer. 40 cubic inches per second. Now, if you're unsure what that represents, look at the units to help yourself out. Seconds is time, so that's dt. Inches cubed is a volume, so this is dV dt equals 40 inches cubed per second. We want to know how fast the depth of the liquid is falling. So we have labeled h, the height of the liquid. So we're looking for dH dt when we know that h is 6 inches deep. So we now have the volume, the height, and this nice picture. We need to find a relationship. The volume equation is going to be 1/3 pi r squared h. Now, if you didn't know that that was the volume equation, you need to put it in the list of things that you're supposed to know. As we take a look, if I were to find a derivative, I recognize that I have a product occurring here. And I can do a product rule to find a derivative, but eventually I'm going to need to find that relationship between r and h. So that takes us back to this picture. You have similar triangles in our picture. And we can write ratios to work with our similar triangles. 7 over 12 is going to be equal to r over h. So what we do know is that 7/12 h is equal to the radius. We're going to replace the radius and substitute in 7 over 12 h. So we now have 1/3 pi 7 over 12 h, and that gets squared multiplied by h. Simplify my problem a little bit. The volume is 1/3 pi multiplied by 49 over 144 h cubed. All right, so now that derivative is not as tough as doing a product rule. So that's why we found that nice little relationship. And when we find our derivative, dv dt is equal to, keep your constants, 1/3 pi 49 over 144 multiplied by 3h squared dh dt. All right, so look at your variables. Do we know dv dt? That's what we do know. That's 40. H is equal to 6. And dh dt is the question. So now we can do our substitution. We know that 40, this is flowing out, so that's negative 40, equals 1/3, here's your pi, multiplied by your 49 over 144, times your 3, h is 6, so that's 36, dh dt. Take a moment, solve for dh dt, and what we know is that dh dt is negative 60 over 7. Now, what's it measured in? It's measured in a height. Well, height in this problem would be inches, and time, so that would be inches per hour. You want to make certain that you answer the question. How fast is the depth of the liquid falling? You would write in a sentence, the depth is falling at a rate of negative 60 over 7 inches per hour. So as we look at example 7, we have a typical shadow problem. A man 6 feet tall walks at a rate of 5 feet per second toward a light that is 20 feet above the ground. When he is 10 feet from the base of the light, we want to know at what rate is the length of his shadow changing. Let's draw the light. It's not moving. It's 20 feet tall. Now, our guy is walking towards the light, and we're going to label that path x. Now, since he's going towards the light, our dx dt is negative 5 feet per second. We're told a person is 6 feet tall, so let's throw in a 6. There we go. And then we want to know at what rate is the length of his shadow changing. Now, the length of the shadow is behind the light, and we're going to label that y. So once again, you should see some similar triangles. Y over 6 is equal to the corresponding side, x plus y over 20. So if we're looking for when the rate of the length of shadow, that's going to be your dy dt when he is 10 feet away. There we go. Cross multiply. 20y equals 6x plus 6y. So we now know 14y equals your 6x. Or y equals 3 over 7x. Now we're ready for a derivative. dy dt equals 3 over 7 dx dt. So now let's substitute. We have that dy dt is equal to negative 15 over 7, and that will be feet per second. So for question A, the sentence we should write is the length of the shadow changes at a rate of negative 15 over 7 feet per second. Now, part B, at what rate is the tip of his shadow moving? All right, so this is where it gets a little strange. What we know is that y is the length of the shadow. But the tip of the shadow is always defined as x plus y. So it's the length of what's in front and behind our man, and that is considered the tip of the shadow, because the sum of those is going to be how we define the tip. In that case, we want to know what is dx dt plus dy dt. So we add our two answers together, and we have -5 minus 15 over 7 feet per second. So the tip of the shadow is changing at a rate of -50 over 7 feet per second. So that would be the tip of the shadow. So I have a couple of problems I want you to practice. 15, 18, 29, 30, and 31. Now, as you practice these problems, remember the process. The process should help you set the problems up. First thing, you should always draw the picture. The picture is essential. On your picture, you're going to label the parts that are moving using variables, label the parts that are not moving using your constants. After you draw a good picture, you should have written down all the given information, use mathematical symbols and equations to explain what all the given pieces of information are, and also write down your question. Understand what you're looking for. Now, tie together the given and the questions to write some sort of equation. Your equation, if you can simplify it as much as possible, that would be really helpful. Afterwards, you're going to find your derivative using implicit differentiation. See how important implicit became? And then you should substitute, make certain you found all the variables that you're looking for, and of course, answer the question in a sentence. So follow these directions to set up each one of the problems, and then I'll be happy to take a look at your work.